Hello, I'm delighted to introduce our final project, Automated Sleep Staging Annotation via Shallow and Deep Learning. Sleep is very important to human health. The sleep disorders can cause a lot of serious health problems, including hypertension, diabetes, or heart attack. According to Hemin et al., about 50 to 70 million people in US are currently suffering from the sleep disorders. The sleep stage actually can be classified by the raw EEG signal. And according to American Academy of Sleep Medicine, the sleep can be characterized into 5 different stages. However, right now, the sleep stage classification is largely in the domain of sleep expert. So the question is, can we automate the process via machine learning? So we try to answer this question by looking at an open source dataset from the Sleep Heart Health Study. It has more than 5,000 subjects with a combined size of more than 300 gigabytes. So the raw EEG signals were sampled at 125 Hz with 2 different channels. And the raw dataset also come with the labels, which are basically the sleep stage for 30-second epoch. And we tried both basic machine learning and deep learning algorithms. For the basic machine learning, we tried decision tree, random forest, multi-layer perceptron, AdaBoost, and logistic regression. For the deep learning, we tried convolutional neural network, recurrent neural network, and recurrent convolution neural network as well. And when looking at the data, we find it is necessary to treat the data in 2 different ways. One is so-called intra-subject, where epochs from one subject are separate into training and test sets. And also, the inter-subject is that all epochs from different subjects can be used for either training and testing. So here are the results for the basic machine learning. We used the scikit-learn package for the machine learning. We used a grid search and with five-fold cross-validation to find the optimum hyperparameters. And we can see the best performance come from multi-layer perceptron with an accuracy about 0.5. And our performance is much worse than the literature report. And we think the reason might be we have smaller data sets. And here are the results for the deep learning for both intra and inter-subject. And we used Keras for the deep learning study. And we can see the deep learning has a much better performance than the basic machine learning. And our CNN result is comparable to the literature report, but for RNN and RCNN, they are much worse than the literature. And I think the possible reason might be we have fewer data, and we haven't got any chance to fine-tune the hyperparameters because that is very time-consuming and computational intense. But however, we try to improve the accuracy by using the ensemble learning. And we try 3 different methods: unweighted average, majority voting, and superlearner. As you can see in the table, the superlearner method achieved a result of 0.8, which is our best model so far. And for a quick conclusion, we have applied a variety of machine learning techniques, both shallow and deep, and we treat the data as intra and inter-subject. And we can see the deep learning algorithm outperformed shallow ones by a large margin. And our best model comes from ensemble approach with a superlearner. And our best result is comparable to the literature report. And finally, we'd like to thank Professor Jimin Sung and all the TAs for their hard work throughout the semester. We really learned a lot from the course.